This episode is brought to you by Skillshare. As we celebrate one more trip around our star, we can look forward to traveling to many new stars. As we wrap up the year 2020, we are also wrapping up our Becoming an Interplanetary Species series with this epilogue on becoming an interstellar species. This is tricky for more reasons than just difficulty of traveling to distant stars and making homes under alien suns, because to become an interstellar species would also imply you were just one species, and that's part of the problem. Interstellar distances are so immense that even objects which could cross our whole world in a second take years to get to the nearest star, and our fastest man-made object would still need longer than all of recorded history to reach that star. Indeed, our galaxy alone is so immense that even signals, let alone spaceships, need as long to cross the galaxy as modern humanity has been around. Even ignoring things like genetic engineering, which might play a big role in humanity settling new worlds, simple exposure to radically more diverse environments than we see on Earth would presumably cause species diversity faster than ships could settle our galaxy, even if traveling at a good fraction of light speed, while at the speeds of our fastest modern spacecraft, an effort to colonize the galaxy would take more like 1 billion years, and 1 billion years is considerably more time than it took for some common ancestor to diverge into humans, cats, dogs, and dinosaurs. So we'll be asking how we can make these trips faster, how we can make them economically, and how we can stay unified as a species, or if we even can or should want to. As we move out of 2020 into 2021, we'll ask how we can visit our first neighboring stars by 2121, and how we can settle the galaxy by 2020, 200,000 years from now. We will obviously need something far better than simple chemical rockets like we use nowadays to achieve that timeline, but we do have the capability to colonize new star systems that way if it came down to it. This is the key notion of what is called a generation ship, something we examined in detail in our generation ship series, and it relies on the notion of essentially building a small, mobile planet, akin to the O'Neill cylinders we discussed as orbital settlements throughout the series. We have nuclear-powered ship designs that, while we never built, do work on very well-grounded principles, see our episode The Nuclear Option for details, and which, depending on designs and hurdles we might encounter when building and deploying them, offer travel speeds of around 1% of light speed, possibly a bit slower, maybe a bit faster, but cutting trips to neighboring stars down to centuries rather than tens of millennia. Those same principles could be used to artificially light, heat, and power the generation ship and its people and ecology for the duration of the trip. This is technology we do already have, though again would need prototyping. Another option often considered though is to put people to sleep or in stasis or on ice, and we looked at this scenario in our Sleeper Ships episode and will discuss freezing people or entire civilizations in a couple weeks. That is one way you can ensure it's modern humans settling every world at least, as they would experience no evolution while frozen for the trip. But the key problem isn't really a problem, namely that the technologies you need in order to restore people you've frozen and killed are the same sorts of technologies that permit radical life extension as well as radical automation. If you have little robots that can fix cells damaged by freezing, you have little robots that can fix cells damaged by aging, little robots that can fix machines on your ship, and little robots that can build machines and organisms from blueprints on other worlds. Similarly, if you have genetic engineering to change people to more easily adapt to your world, you have the technology to keep people at their current biology too. Indeed, we can already do that. We can make digital copies of DNA, we can print DNA, albeit very slowly, and we can implant a printed strand of DNA into an egg, so our interstellar arcs do not need to carry tens of thousands of living copies of a given organism to avoid genetic bottlenecking or even frozen fertilized embryos. If it's important enough to a civilization, even with modern technology, we can get humanity to each world we settle with our modern DNA and keep it that way, if the folks on each of those worlds choose to. That strikes me as unlikely, and of course the same DNA or close enough to count as a single species isn't helping with language and cultural drift. This is the origin of our joke on this show that if we don't find aliens in the galaxy, all we need to do is wait a little while and they'll be around every star. Indeed, only if we can achieve significant trade between neighboring stars is there any real chance that the folks living in your neighboring system will be any more like you than those clear across the galaxy. We looked at interstellar trade recently, and it does seem possible, and we have also looked at a variety of ship propulsion concepts ranging from the near-term to the really advanced or enormous, everything from using antimatter or black holes to run ships, up to moving entire solar systems or even galaxies. But what is likely to be our first interstellar ship, and when? A few minutes ago I said we'd ask how to get to our neighboring stars by 2121, and if that's the case, given that the nearest is over 4 light years away, and we have not funded let alone started building an interstellar ship, the most optimistic production timeline would require traveling at 5% of light speed to get a ship there by 2121. This is a velocity that might be reachable by fission fragment or post-nuclear propulsion, as shooting nukes out the back of a ship to ride the explosion, and should be achievable by a fusion drive if we ever got fusion working. Indeed, given the joke about fusion development always hinges on it being 20 years off, were that to be true, commercial fusion by 2140, we probably could get a ship built within a decade, and then you only need to get to 6% of light speed to reach Proxima Centauri in the 70 years remaining. If fusion is great for interplanetary travel, it makes the whole process vastly cheaper and easier. In truth, so does fission, though fusion would be better in almost every respect and by a wide margin. A fully developed solar economy is much easier to reach with nuclear options, but neither truly permits spaceships that can reach the nearest star in a mere generation, at least not directly. We might do much better with light pushing on our spaceships, and the sun is an abundant source of light from its own internal fusion. We often talk on the show about using focused light or lasers to push ships up to high speeds, and for slowing them down too, though that is harder especially in an uncolonized new star system. This offers near light speed travel, though does not help with the interstellar debris and collision issue much, and that requires some explaining. Space is pretty empty, interstellar space even more so, but not so empty you can expect to fly several trillion miles or kilometers without encountering something the size of a piece of gravel. In and of itself, that pebble is just a pebble, probably containing no more energy than a bullet, but kinetic energy and damage from impacts has to do with relative speeds when colliding, and there's a lot of energy involved in those kind of speeds we contemplate for interstellar travel. Now, I've heard people say that even hitting an atom would destroy a ship, and that's hyperbole. We routinely get hit by relativistic atoms, relativistic meaning moving at a decent fraction of light speed. It's not healthy, but more in the way radiation isn't healthy, and even fairly thin shielding protects you from that, and the concern is about being hit by trillions of those per person, not one per ship. On the other hand, cosmic dust grains vary in mass a lot. The ones hitting Earth range from 10 to the negative 16th to 10 to the negative 4th kilograms, a variation of a trillion-fold. And hitting the latter kind would be on order of a small nuke at near light speeds, while the smaller kind carries less energy than a mundane object we might throw, like a baseball, and those smaller dust grains are vastly more common. Incidentally, a dust grain massing 10 to the negative 16 kilograms, small as that sounds, still contains billions of atoms. The faster you go, the more frequently you collide with objects, or need to detect and avoid or destroy them, and the more energy it takes to reach that speed, such that there is likely to be a natural optimal speed way lower than light speed that ships move at between stars. That may vary based on many factors, including the mission's purpose and priority, but it isn't likely to be over half light speed and may be as low as 1%. At that speed, you have to be hitting rocks bigger than humans could comfortably lift to be getting nuked by the collisions, and you have a lot more time to dodge, and much bigger targets to detect and hit if you can't, but I would guess that it would be collision avoidance and management that represents the real limits on space travel speeds, not energy or fuel, for the future. One thing often ignored in science fiction, where faster light travel is ubiquitous, is that every pebble you hit, every dust grain at those speeds, would actually have infinite energy. That's on top of the other issues common with faster light travel, like having a black hole behind you and a white hole in front, or causing time travel paradoxes just from flipping the engine on, and on generally requiring exotic matter that probably cannot exist in nature. So we have a handful of plausible near-term drive methods for interstellar spaceships that won't take whole historical epochs to visit nearby systems. Fission, fusion, micro black holes, antimatter, and focused light pushing on solar sails, and basically that list is slowest to fastest. The light beaming trick, be it visible light or other spectra, has the speed advantage because it doesn't require carrying all your fuel, so your speed with it depends on how big a beam you can send, how long you can keep it focused on a target, and how much energy your ship can handle without melting. and how well your ship can handle space debris and collision issues. Micro black holes and antimatter permit much easier control and braking if you can do either, but both are a lot more high-tech and require some big assumptions. See our episodes on antimatter factories or black hole ships for further discussion. Laser propulsion, on the other hand, we can do right now. It's lower tech than fusion in that regard, since we don't have controlled fusion. Emphasis on controlled though. We have had the ability to do fusion since even before we invented fusion bombs in the 1950s. A hydrogen bomb is a fusion device, and it really is less crazy than it sounds to make a fusion-propelled ship driven by hydrogen bombs. Almost all of these ships have to be pretty big though, whether they are manned or not. You can make a flyby probe designed to race through a star system at near-light speeds that you shoved up to those speeds with a laser, but when we're talking about stopping, the dynamics change a lot. So our first interstellar ship is likely to be an unmanned probe pushed by light. Note that I'm not including some of our interplanetary probes that have left our solar system already. They will take tens of thousands of years to get anywhere, will have broken by then, and I'd actually bet they won't ever arrive at other systems. The final destination of Voyager 1 is probably a museum. Someone is likely to pick it up and either bring it home or to some colony, and I'd say there's a pretty good chance it will be in the Smithsonian before we have an interstellar colony with a museum. Or not, interstellar arcs need to be big things, especially if you're not using various post-biological approaches, like growing your colonists on-site from databases. Such being the case, you probably would have museums on those ships. We often picture those as having thousands of people and a voyage of a century or more, and if you look at towns in that age and population size, like my hometown of Geneva, many do have museums, as mine does for instance. Bit of a tangent, but it's worth remembering that these colony ships of the generation ship variety will generally develop pretty complex civilizations on board even before they actually arrive and found a colony. What's the fastest way to get a human colony going though? With technology that is reasonably plausible anyway. We talk a lot about getting giant generation ships to other stars, and that tends to be the preference because it works best for modern humans, but if our goal is to get humans established in other solar systems fastest, how can we do it? Two pivotal terms there are fastest and human, and part of why we are talking about becoming an interplanetary species. That term human can be real ambiguous, and how we define it matters a lot if we're contemplating fastest methods. More than just for who gets that first colony in, and on what date too. In general, whatever you do first has better odds of being what you do most. I don't mean this in a militant sense though, as we discussed before, you cannot beat everyone to the punch with something like self-replicating spacecraft trying to claim all the cosmos. Any ship you send out has to slow down to colonize, and for ships that have onboard fuel supplies, two identical ones, one meant to slow down and one meant to reach maximum speed, the latter can move twice as fast. You need to be able to slow down to colonize something, you do not need to slow down to ram something. Quite to the contrary, you do more damage by speeding up. So anything obeying the rocket equation, whether the fuel is H-bombs, fusion drives, antimatter, or a portable black hole, can be easily detected on launch and caught up to and destroyed by a pursuing craft using the same propulsion design, or several smaller ones. There is no plausible scenario for escape, as every time you light your engines up for a course correction, you will become visible again and very much so, and your trajectory is easily calculated. The pursuit ships will always have an edge in maneuverability as well as detectability too, since their drives point away from you, but yours point back toward them and toward the homeworld's detection arrays too. Laser pushing avoids the rocket fuel issue, but actually results in you being more detectable, lower in maneuverability, and they can also attack your pushing beams built here at home, or just block them and use that energy instead, such as for pushing their own interceptors after you. Such being the case, you can have an interstellar colonization race, but there has to be an element of non-hostility involved, because if you try to grab everything for yourself, everyone else can dogpile you very easily and wreck your ships, even with years of head start. There's also plenty to choose from and divide up too. The nearest star may be over 4 light years away, but space is 3-dimensional. There's over 1,000 stars within a volume 10 times wider than that, and over 1 million in an area 100 times wider. And even that is a volume that would barely qualify as a single tiny closet in the great city of the galaxy. So if you try to seize them all, unless you have such an advantage you could conquer all system first anyway, you will lose, and there's so many out there that there's no real shortage. Who gets them then is less an issue than how they get them. Folks willing to send their minds by hard drive to be inserted into an android body on the other side can get there faster, for instance, and so can artificial intelligence, though that might be a redundant statement to many people. But this doesn't mean their civilization is colonizing by sending digital people everywhere. They don't really need to. You can send the great big generation ships carrying people, regular people, almost as fast as the other follow-up ships carrying less organic materials. The same top speed for the ship, but generation ships have to accelerate pretty slowly, potentially needing several years to get up to cruising speed and back down, while something with no organic components can probably get to speed in mere days or weeks. For voyages of thousands of light years that means little, but to colonize a neighboring system it means a lot. Now the concept of a von Neumann probe, a computer probe that arrives in systems and replicates, is a popular one, but how intelligent it is depends on your available technology, and more on your confidence in it not turning crazy or traitor on you. That can be an AI you've rigorously programmed, or an uploaded human mind, or one heavy on cyborg components and mind augmentation, and we see examples of that in science fiction, such as Dennis E. Taylor's Barbaverse series, or Dust's Chrysalis. For that first interstellar colony, we need a lot of robotic automation to build the ship and laser pushing system, and we'll need it on the other end too, so folks are likely to already be fairly comfortable with simple AI. However, again for that first set of colonies, I cannot see us trusting an entirely artificial intelligence. On the other hand, a digitized human selected for their devotion to the project and reliability, or someone with a lot of modifications to handle large accelerations and oversee robot drones, probably will be more acceptable. The key thing is that the fastest way to another system right now is the laser pushing system, but there's nothing to slow you down on the other side, and the best way to slow is to engage in a literal crash project, like we looked at in Exodus Fleet, where some vanguard chases forward of your fleet on a sun-dive vector with a solar sail, being slowed some by the plummet, but using the energy it receives to power a laser beam backwards, which hits another vanguard who is slowed more, who does it to another, and so on, until you can actually get a stationary laser array around the sun to slow your fleet. That might work with sub-intelligent AI, it's not that complex a process, but it works best if it's being controlled by something intelligent who's reasonably close, not light months behind. It probably does not require human-level intelligence either way, but might benefit from it. Thing is, the system Vanguard controller can be Vanguard for a lot of things, because a great big mirror and transmission arrays also is great for getting signals from home, not just slowing incoming spaceships, and it's also a great power supply for early resource harvesting robots. Regardless of how you colonize, the Vanguard is pretty much always going to be a robot with some construction capacity and some intelligence, and probably as little of the latter as needed unless the Vanguard is actually an intelligence or intelligences we classify as regular old colonists. If your civilization considers a human-level AI a person, then sending one as your Vanguard probe is not sending an unmanned probe, just one lacking biology. From there they can slow incoming ARC ships, whether they are generation ships or carrying frozen people, or they could be receiving ships full of hard drives with intelligences on them, or building big dishes for receiving transmitted minds. The former process is slower but maybe much cheaper and safer. Or they might be 3D printing equipment, including basic biology. We more or less have the technology to clone humans and raise them in vats or bags in modern times. We don't do it though for ethical concerns, so it's hard to say what sort of challenges growing a bunch of colonists in tanks might have, but it should be doable too. It might be easier to do this from entirely frozen samples of human biological material, same for other flora and fauna, but we can print DNA, and a basic human cell, or other cell, is not beyond the bounds of doable either, especially given that you already have self-replicating machines to be even contemplating this as a colonization method. The upside is that you can pretty much pick your methods because none has a vast advantage over the others. A generation ship kilometers wide and long might seem far harder than a tiny shuttle containing hard drives and self-replicating robots, but the key component there was self-replicating robots. If you are launching a lot of robots to systems to arrive and replicate more of themselves to build your colony, then send out copies to other systems, you can just as easily make the first stop some uninhabited asteroid in your own system and have it build a big ship. It would take vastly more energy to get it moving and stopped at the other side, but it's a one-time investment either way, and an uninhabited star system has tons of energy being wasted already, so it only matters if you're short of it in your home system. And of course you're not in early colonization periods, since you can just tell those little robots to build power collectors. You're many millennia away from having enough people in your home system to be worried about power consumption by spaceships, as we looked at recently in Interstellar Trade. In such a scenario though, whether it is the year 2121 or the year 3131, your interstellar ships are arriving at new systems after your own home star system has started down the path to being a Kardashev 2 civilization, working to being a Dyson swarm, because that exact same technology for colonizing those systems lets you mass produce cheap solar collectors here too, and you want them for sending out your ships initially. See last week's episode on Kardashev 2 civilizations for more discussion of that notion. But the critical idea is that you're already on your way to being a K2 civilization here before your first colony ships arrive, and there is no reason that couldn't happen in the next century. It is weird to think things might move that fast, especially after all the long delays getting to Mars or even setting up a moon base, 50 years and counting since we first traveled to the moon, and not much less since we last went there. But that is often the nature of growth and expansion. Once the tipping point is hit, the avalanche begins. Before that, you crawl. I don't think we will have our first interstellar colony founded by 2121, but we might well have the ships headed out by then, and the weird thing is that it's not much harder to send those ships out than to colonize any of the planets in our own solar system. Plus, as soon as we do have those moons and asteroid bases and orbital settlements, we have all the ingredients needed for interstellar travel. All those automated constructors, power satellites and mirrors, and giant orbital settlements are easily modified and repurposed to create our interstellar infrastructure. In many ways, the jump from an interplanetary species to an interstellar one is far shorter than our jump to becoming an interplanetary species. So becoming an interstellar species will likely follow on within the same century we become an interplanetary one. At least the launch will, there is no getting around the timelines. Whether you can only get those ships up to a few percent of light speed or to within a few percent of light speed is the difference between colonizing our galaxy in a couple 100,000 years or several million, but it still requires timelines beyond any prior human endeavor. When you consider though that there are hundreds of billions of star systems out there, we are likely to be colonizing hundreds if not hundreds of thousands every single year once we get rolling. It is very likely we could send colony ships out at half light speed or better, especially if most of those ships were originating from this solar system and making the lion's share of the journey through regions of space already colonized and with the travel infrastructure in place. In that case, we may well have managed to settle every single star in the galaxy by 2020, 200,000 years from now. That just leaves the question of if it is worth doing and if most people will think it is. One key point to understand is that it doesn't require any sort of unity or consensus, any more than early human tribes spreading around our planet did. So in that regard, it doesn't matter if most people's answer to the question of if we should colonize other worlds is indifference. As technology improves, it gets easier and easier to do so, and requires less agreement and less hardship to the civilization to invest in the effort. But it is an investment. The gains of becoming an interplanetary species are huge and local, those on Earth will directly benefit from it enormously, and migration around the solar system will be relatively easy. This is less so for interstellar travel, but as we discussed today, that next jump is less difficult, if far more time consuming overall. 2020 has been a rough year, and not one that encourages us to look to the stars with optimism, but victory is far closer to hand than most would think. And if there's one thing this year has proven, it's that we are a tough species and we don't give up easily. They say that the sky is the limit, but it doesn't have to be. Indeed, it's just the gateway to limitless opportunities. Happy New Year! So that wraps us up for 2020, but we have 2021 just ahead and we'll get to our upcoming schedule along with some in-year announcements and thoughts in just a moment. First though, one thing 2020 has shown us all is the importance of being able to function online, and that's everything from socializing to working and learning. It's also taught us the importance of flexibility, and a good contingency plan you can have in place is to have a hobby or two you can enjoy. That might be a way to earn money. We talk a lot about the future of humanity here, but we all have our own individual futures, and one way to be a lot more secure and happy in yours is to have some hobbies you enjoy that can potentially be turned into your new career or business. A lot of folks are busy making their New Year's resolutions up, and what I'd strongly advise is to choose to find some hobby you think you would enjoy that could also serve as that fallback job, side income, or dream business of working for yourself at something you love, which I can testify to as a dream well worth pursuing. If you're looking for a place to find hobbies that have potential financial rewards, our partners over at Skillshare have an amazing collection of them on many topics and at many skill levels. But I would suggest trying out Emma Gannon's Discovering Success, 7 exercises to uncover your purpose, passion, and path, as a way to help you see what interests and talents you might already have that might become your hobby that leads to your dream job. Perhaps you're trying to adjust to working in a new environment or just looking to pick up some new skill or hobby. Skillshare has a course for it, whether you're a beginner, a pro, a dabbler, or a master. Skillshare has thousands of classes on a wide variety of topics from experts to help you learn. Skillshare is an online learning community for creatives where millions come together to take their next step in their creative journey, and members get unlimited access to thousands of inspiring classes, with hands-on projects and feedback from a community of millions. If you'd like to give it a try, the first 1,000 people to click the link in my episode description will get a free trial of Skillshare Premium so you can explore your creativity. Act now and start learning today. So 2020 has been quite a year, for good and ill, and most of us will be glad to see the backside of it. I tend to feel a little guilty at what a good year it's been for myself, though I certainly won't miss either. I mentioned dream jobs earlier, and 2020 has continued to let me do mine. Our show has continued to grow, and for those of you who joined us this year, thank you for coming on board, and I hope you enjoy 2021 too. In recent years, I've tended to write the episodes 2 to 3 months out, except for the sponsor reads and schedule at the ends of episodes, which I usually do the week before they air. So I'm busy drafting our March 11th episode, Killing Stars, as I write and record our schedule here on December 21st for our December 31st episode. It's my habit to show the next 2 to 5 episodes on the schedule at the end of each episode, but if you're curious, there is a spreadsheet I do the full schedule on a few months out and keep chronological lists of episodes and links them in, though episodes more than a month out are tentative for air dates even when already written. And I will attach a link for that in the episode's description if you want to see the full roster of what's planned for next year, or go see what you might have missed from previous years. As I mentioned, it's been a good year for me, the show has done well when I got married, but one word of advice I'd offer folks is that an awful lot of how your year goes is about how you choose to look at it. A glass half empty, glass half full, or yum, I just drank a tasty drink and still have half of it left. Or maybe even, hey, I have a cool new drink I can recommend to friends who might enjoy it and could use something to improve their mood. Cheering other folks up is often a good way to cheer yourself up. I feel like in the long term, 2020 will be a net positive for humanity. Challenges often bring innovations and solutions and help sweep away stagnation, but rising to challenges is its own reward a lot too. I ended today's episode with a reminder that the sky isn't the limit, and I think that's a good note to end the year on too, with a reminder that challenges make us stronger and better, so the journey is often as important as the destination. I often get asked how I can stay so upbeat about my life, the future, and about humanity in general. And I would say it helps when you can think of those challenges as benefits. I wouldn't say we should be glad for hardship and view it as a gift that might border on masochism, but taking time to think about past or current hardships and how they had silver linings, like giving you a new skill or bringing you closer to a friend you went through the crisis with, does help you stay upbeat. And it is almost always easier to get through life with that mindset and attitude, even if just because your stress levels are lower and folks tend to enjoy your company more. Hopefully watching this show and what we see for the future helps you do that too. Speaking of the show and the future, this may be the end of the year, but we're still here every Thursday morning, and we'll be again this Thursday, January 7th, to look at earlier times and civilizations, indeed the earliest possible times and civilizations, as we take a look at civilizations at the beginning of time. The week after that, we'll be looking at civilizations even colder than ours is this winter in Cryonics Frozen Civilizations. For alerts when those and other episodes come out, make sure to subscribe to our channel here on YouTube, or the audio-only versions available on iTunes, Spotify, and SoundCloud. If you would like to help support future episodes, you can donate to us or become a sponsor for the show on Patreon. All those options, along with our social media forums on Facebook, Reddit, Discord, Twitter, and our website, are linked in the episode description. Until next year, thanks for watching, and have a happy new year!